My name is Oscar. I'm a researcher at the Universidad del Valle de Guatemala. My research interests are in program transformation, programming education research, and more recently, online learning to rank. And well, these topics are sort of connected with today's talk in the sense that overall I have an interest in making programmers more efficient in their work. So we'll go into that in more detail. So we're going to be talking today about prototyping Spark programs with Excel out of all tools. This is our agenda. I will start with a general problem statement and the motivation that led me to this talk. I will also briefly present an architecture diagram, sort of like a running example. Then I will introduce program transformation, sort of define it. That will lead me into a program transformation pipeline, which is the core of today's talk. And specifically, we will go touch a little bit on code-to-code transformation, which is a specific kind of program transformation. Then we will go into parsing of Excel formulas. We'll touch on a grammar for that. We'll see that with that grammar, we can have a parse tree as well. Then we will continue into using a tool called Excel Parser, which does exactly that, produces a parse tree. Finally, we will look at Excel. This is more of a conceptual point. We will look at Excel as a domain-specific language, and we'll see how that's useful for generating code, or at least as a starting point. I had a demo planned for this session, but because of the jet lag issue, I will have to show it offline for those of you who are interested. So I'll probably leave some time, hopefully, for Q&A. So a little disclaimer just before starting. This is actually ongoing research. We haven't measured anything yet, but we do have a research prototype, which is a program transformation pipeline for a few Excel formulas, and we have found nice results on that. So I'll focus on that program transformation pipeline. Now, this is the like the starting point, the problem statement as I started with, and it's basically that, well, there seems to be some sort of Spark programs that can be prototyped with Excel. And so if we take the Excel formulas, we can manually translate those into Scala code. So that's doable, but it's tedious and error prone, not to mention slow. So with this, I started thinking, well, there seems to be a straight path between what I call column-oriented Excel programs, and programs is in between quotes there, because well, not many people will think of Excel as a programming language, but there are researchers out there who will tell you that spreadsheets are code, for example. So there seems to be a straight path that we can take Excel and translate that over to a Spark program, and specifically a type of Excel program that makes use of the DataFrames API. But as we were touching on, manually translating those Excel formulas is tedious and error prone. So this led me to think, well, would be kind of nice if there was some sort of an Excel compiler. And if there was, then we could just generate code, and this would all be automatic. So that the problem statement evolved a little bit. Well, given that there's what I started calling column-oriented Excel applications, and those can be manually translated, as we've seen. Well, the problem is actually finding a way to automate that translation process into a data pipeline where programs can be prototyped in Excel, and you have the output a Scala program that runs on Spark. So it could be also Python, but in the demo I had planned, it was Scala. And so overall, the motivation is to automatically translate Excel formulas to Spark, and ideally have that available in a data science notebook so that we can iterate on that. So this is the architecture diagram that I was mentioning. Imagine you're a business analyst at a bank somewhere, and you have your Excel program, you want to translate that, so that's over by the far left. There's Excel formulas coming out of a blue bucket there, and there's also columnar data, maybe a CSV file. We take those as inputs for a black box that generates Scala code that runs on Spark. And, well, we might even be able to index that on Elasticsearch. And since we have it, we have the Scala code, we can iterate on it through a data science notebook, maybe refine it a little bit, maybe do a little bit of more specific things. Then we could take that indexed code, take a snapshot of it, store it on S3, so up by the red bucket there. And once it's there, another team, maybe there's another development team, can take that and restore it on an Elasticsearch service. So indexing of programs here plays a central role. And just a quick advert, at this same time tomorrow, I'm giving a talk on having a Spark cluster with Elasticsearch running inside. That's sort of related to this. But for now, let's go back to program transformation. So what is program transformation? Well, it's a type of transformation, a type of operation rather, that takes as input a computer program and it outputs or generates another computer program. So if we go back to our architecture, that's the black box here shown inside the green circle. So as input, we have Excel formulas and columnar data, and as output, we have Scala code. That's shown more clearly here, where the purple arrow is the actual transformation step from Excel to Scala and Spark. Now, this is actually a type of program transformation which is called a code-to-code transformation, where that's a kind of transformation in which the input to the code generator is typically either a parse tree or an abstract syntax tree. But in order to do that, we need a grammar. So as I was going through this, I thought, well, what am I thinking about? What am I talking about here? So what is the process? We need a parse tree. We have Excel formulas. And, well, if we were able to get those into a parse tree, we could actually generate Scala code from that. But again, we need a grammar for it. So I found this paper. So the internet is a great place for science. And to quote Isaac Newton here, if I have seen further, it is by standing upon the shoulders of giants. So a place to find those giants is on the internet. And I've actually found this paper by Evdimia Ivaloglu, David Huppelmann, and Felina Hermans from Delft University of Technology. And in that paper, they provide a grammar for Excel formulas, and they also provide Excel parser, which we'll see in the next slide. So here, for example, we see a flow diagram of a production rule that basically parses an Excel formula. So this is an Excel parser. You give it an Excel formula. For example, over by the far left, down, we see sum A comma C. And that generates, well, it parses the formula and it produces this nice diagram here, which is what we were looking for, our parse tree. So that's great. We have a parse tree. We can generate code, conceptually at least. Well, and this is where this slide comes in. I think an important step is how we think of Excel. Actually, I see it as a prototyping tool, a tool that can be used to prototype big data applications in this case. And more specifically, I see it as a domain-specific language. Domain-specific, so what specific domain are we talking about? Well, the domain of column-oriented applications, data applications. So Excel parser gives us a parse tree, and from that, we can parse an Excel formula and generate code from that, which is actually a great starting point. But so back to the question, how do you generate code from parsed Excel formulas? Well, an elegant way, quoted here from a blog post, is to take the abstract syntax tree, write a class for each non-terminal node, and generate simply in between quotes have that generate the piece of code that you're interested in. Well, actually, a more practical way, however, is to take the parse tree rather than the abstract syntax tree, write a pretty printer for it that produces code in the target language, Scala in this case. So let's go through an example of that. We have our parse tree produced by Excel parser, corresponding to the formula over by the far upper right, sum a comma c, and we have the Scala code that makes use of the DataFrames API down by the bottom right. So there's very useful information in the parse tree. Like, for instance, the fact that we're dealing with a function here, namely sum function, shown in the small circle by the left. We're also dealing with integers, namely column C and column A. We can use that information, so including the names of the columns and the types of data that we're dealing with. And we can use that to actually generate code either from an AST or from a parse tree. So I had prepared a demo. Anyone who's interested, I'm very happy to show that offline. In the demo, basically I was taking the bike sharing data set. There's two columns there that are summed up together. So I would input an Excel formula for summing those. That would produce Scala code that makes use of the DataFrames API. I would copy that over to a data science notebook, run it, and show you that the same results are produced if we were to just sum them directly with some other method. So I can show that offline. So what have we seen? Well, we've seen that a very specific type of big data applications, namely what I call column-oriented Excel applications, can serve as prototypes for Spark programs. We looked at data transformation. We saw how we can model that as part of a pipeline. We went into a little bit more detail, and we reasoned that that's actually a code-to-code transformation because we have input code and we have output code. Well, we also went into a little bit of detail on how to parse Excel formulas. There's a grammar for that that's published as part of a paper. There's also a tool for that called the Excel parser that gives us a parse tree. And from that parse tree, and an additional conceptual step, which is looking at Excel as a domain-specific language, we can generate code. And we saw how that process can be accomplished. Maybe one small detail to mention here is the demo and the prototype we've built so far is able to translate up to 5 Excel formulas, but apparently there's like 500 of them. So there's a long way to go still. And lastly, well, we didn't see the demo, but I can show that offline. Oh yeah, the next steps. So next steps, translating the close to 500 Excel formulas out there. I was thinking, well, it'd be really neat if there was a way to also model machine learning in Excel. So have a business analyst be able to build a machine learning pipeline just using Excel. That would be wonderful, I think. And so to sum up, this is about producing prototypes for data pipelines and hopefully in the future machine learning pipelines in Excel. So now I will open up for questions. Just a reminder, there's at the same time in the Copper Hall room, I will be giving another talk about running Elasticsearch inside your Spark cluster. So with that, I open up for questions. Thank you. This is my email and my Twitter handle.
Thanks for the talk. Just to check, have you ran some performance tests on that to see how quickly basically translates that and could run it from an Excel sheet? Because analysts, of course, would like to, they're used to Excel, right? So everything is almost instantaneously. So how long will it take to translate the whole process into Spark in that sense? Because Scala compilers are essentially a bit slower than Java, for example, and things like that.
So no, we haven't run any formal performance tests. Just from looking at it, it should be rather quick, unless the formulas are like you have maybe 20 levels of embedding inside a formula or something like that. That could be a little bit troublesome, perhaps, but we haven't really tested it thus far. But that's actually the point of the research. Once we have the 500 Excel formulas, seeing how it performs.
There is this freeware LibreOffice, OpenOffice, which doing interpreting Excel formulas already in code, their own code. Did you consider using their works for your transformation?
Not really. Well, I didn't know that there was.
Yes, but that's a freeware Excel compatible. You can import Excel sheets into their tool, so there should be some transformation in it.
Sure. Well, I have come across programs in C++, for example, that translate. Well, I'm not sure if it's in C++, but the point is, there's programs out there that allow you to translate Excel into C++ code. But the thing here is that it's not making use of a cluster computing framework like Spark. So the interesting bit here is to run that on Spark.
Any other questions? All right, let's give one more round of applause.
Thank you.